Hello everyone, Ike here, and today we'll be looking at the part 2 of sets and operations on sets. Today specifically we are looking at ways of describing a set. A set can be described in 3 different ways. So let's have our heading. Ways of describing sets. Okay, so the first way we can describe a set is 1. Listing its members. Listing the members of a set. Remember, we've already talked about cardinality of a set, numbers of a set, where we looked at set notation and definition of a set in our previous tutorial. Now, to understand this, listing its members, let's look at this example. We have P, the set P. Remember, every set is denoted with capital letters, not small letters, P. So the set P has as its members 2, 3, 5, 7, and 11. The curly brackets, or we can also have the set Q, curly bracket 1, 2, 3, 4, 5. Then we have this ellipsis. These 3 dots are called together is called ellipsis. Ellipsis. This word, we call it ellipsis. These 3 dots, ellipsis. Alright, so let's erase that. Ellipsis. Okay, let's close our curly bracket. Alright, so we have this example listing the members of a set. So for example, we have described the set P and set Q. To describe it, we have listed the members. So the members of set P 2, 3, 5, 7, 11 are these, okay, are these. So we have described the set P. So the set Q2 is described as 1, 2, 3, 4, 5. Then the ellipsis, meaning it's a continuation, doesn't end. There are other members which we haven't listed. So if you look at the order 1, 2, 3, 4, 5, looking at the pattern, you know, say the next one will be what, 6, 7, 8, 9, 10, and it goes on and on. Okay. So basically, the ellipsis that we talked about represent all the members that have not been listed. Okay, so when you see a set with this ellipsis, the 3 dots, it means that there are other members that have not been listed. And to know the members that have not been listed, you look at the pattern of the members. This is 1, 2, 3, 4, 5. So it continues 6, 7, 8, 9, 10 in that order. Alright, so let's move on. So the second way we can describe a set The second way we can describe a set is by giving a word description of its members or defining a property of that set. Let's write it down. Okay. Just a moment. Okay, so we are done. Okay, all right, so number 2. The second way we can describe a set so by giving a word description of its members. So basically what you do is that you describe the property of the members, or we define a property of the set. Remember, in our first lesson, we spoke about a set being a well-defined, a collection of a well-defined collection of objects of the same kind. So we said a set should be well-defined. It should be a collection of objects, not just a single object, and it should be of the same kind. So we are going to use these, our examples, the set P and Q as examples, these sets. Okay, now if you look at this set P, how would you describe it? We are trying to give a word description of the members, or we define the property of this set. So if you look at set P, the members are 2, 3, 4, 7, and 11. What comes to mind? These numbers can only be divided by themselves and 1. So that means that they are what? They are prime numbers. They are prime numbers. So we say that set P, in giving it a word description, we can say that set P, they are prime numbers. Prime numbers less than 12. Okay, let me write this one. It's a bit of prime numbers less than 12. Okay, so set P can be described using word description as what? Set P is the set of prime numbers less than 12. Now let's look at set Q. This is 1, 2, 3, 4, 5. Then we have our ellipsis, the 3 dots here. What do you think? This is Q. Is the set of positive integers. There is no negative in any of the words. Sorry, any of the numbers. Positive integers. Okay, so this is word description. This is another way of describing a set. Positive integers. Now, let's look at the third way. The third way we will use what we call a set builder notation. Okay. All right. So number 3, the third way of describing sets. So, like I was saying, the third one, we are going to use a set builder notation. That's the third way of describing a set. So, in an exam, you can be presented with a set question, and there can be that set question. You could be given a word description. The set will be defined as a word description, something like this. Okay, something like what we have here. This, or you could be given the set by having its members listed like this or like that. Okay, so when you see a set question presented in that way, you shouldn't get scared. Okay, it's still set. Now, let's look at the third one using a set builder notation. This process looks a bit more mathematical, but it's very simple. Now, let's take our prime numbers. Let me list them here so that you can remember our prime numbers. Just a moment. Remember, we listed our prime numbers, set P. The set P as the members are 2, 3, 5, 7, and 11. Okay, so this is the first way of describing a set, like we talked about, by listing the members of the set. Now we want to use a set builder notation to describe the set P. Now to do that, this is how we go about it. Let's scroll this up. So using the set builder notation, this is how we write it. P equals X, and this dot looks like a colon. We say that in maths, we interpret it as such that. It's read as such that. Okay, that's how we read it, such that. So X is such that. Then we write it. Our notation such that 1, okay, X 12, and we close our set. Now, if you look at the set, So where x is a prime number, so x is a prime number. Okay, so basically we are saying that x, the numbers between 1 and 12, 1, let me change the color to make it clearer. The numbers between 1 and 12 are prime numbers, and the prime numbers are these: 2, 3, 5, 7, 11. So when you see the sign, the x is here, so this is what greater than the big side, the open side, this side open is facing the x, so that means that x is greater than 1. Okay, x, sorry about that. Okay, so x is greater than 1 or equal to 1. X is greater than 1 or equal to 1. That's what the sign means. X is greater than 1 or equal to 1. And here we have x is less than 12 or equal to 12. Okay, but when you look at this symbol, you notice that it's a bit problematic. Okay, why is it problematic? Because there is no 1 here, just a moment please. There is no 1 here, and there is no 12 here, and x is not equal to 12, neither x is equal to 1. So that makes the symbol wrong. You see that? X is not equal to 1. So x is the prime numbers. Now, you must be able to spot these errors, otherwise it could cost you. You see it? Okay, so let's remove this. Now we are going to express it correctly. So this is wrong. I hope you noticed it. Alright, so let's express it correctly. It should be P x is such that, let's bring this closer, x is such that. Okay, now let's understand this. So the x is representing all of this. That's what the x is representing. Okay, now you can see that the numbers, we don't have 1, we don't have 12, so we can say x is greater than 1. Okay, because it starts from 2. All right, x is greater than 1, so our x is in the middle. I hope you're following. So x is greater than what? 1. Good. So if you look at this, we are looking at two extremes, the left side and the right side. So now we have defined the property of the left side, that our x, representing the numbers in circle in red, is greater than 1. So we know that the members of the set P, they are greater than 1. That is clear. But what are they less by? If you look here, we have 11. There is no 12. So we say what? They are less than 12. So we go down again. So we say x is what? Is less than, we say, the part of the equal to inequality sign the smaller part, since the smaller part is facing the x, it means that the x is less than. Here you see that the bigger part is facing the x. It means that x is what? Greater than 1. Okay, so you take note of that. The part which is facing the variable will determine whether it is greater than or equal to. Is greater than or less than. All right. Sorry. Okay. No, I'll write it. Is greater than x, less than 12. So this is our set builder notation, and this is correct. So you see the difference between this and that. See the difference between this and this. So you see this one, there is an equal to sign, the one in brackets, okay, and this one is a greater than sign. So this is the correct one. This is wrong. Okay, so let's look at this. Which instances do we use the x is equal to or greater than? So let me give you this example. We have n. Let's say we have this set, okay? This set n equal to 1, 2, 3, 4, 5. Then we have this ellipsis, okay? Now, if you look at this set carefully, let me add something here in the mix. I'm adding this. So 10. Alright. So if you look at this set carefully, you see that you have the ellipsis here, 1, 2, 3, 4, 5. Then ellipsis, then it ends at 10. You know, this a way of describing the set using the first method by listing the members. Okay, so the ellipsis here says that indicates to us that there are some missing numbers, and the set ends at 10. So that means that the missing numbers are between what? 5 and 10. So looking at the pattern 1, 2, 3, 4, 5, it is safe to conclude that what? The missing numbers are from what? 6, 7, 8, 9. So these are the missing numbers. Okay, so if you put them here, it follows the pattern beautifully. Now the question is, how do we express this using the set builder notation? Now remember, we've already discussed the third method. So we can write this using the set builder notation as what? Always remember, the set builder notation begins with x is such that, see, you write, so the x is representing this variable, so it is safe to say x is greater than or equal to 1, because we have 1 here is equal to 1, and it's also greater than 1 because we have 2, 3, 4, 5. So it fulfills this condition at the left end, okay, at this end. Now let's look at this end. This end. We've looked at this end, this end. So 10. So 10, we can say it is what? Less than 10 or equal to 10. So this is how we use the set builder notation to describe the set. So sometimes you can be given a set in this builder notation. You should be able to understand it and be able to express it. So when you see equal to, greater than or less than equal to, it means that the number is a member of that set. Okay, when anytime you see equal to or greater than or less than, it means that that number which is greater than or less than is part of it. Once you see this equal to sign here as part of the inequality sign, it means that the number is part. Okay, it's a member of the set. All right, so this is all we have time for today, and I hope you understood everything we discussed. So to recap quickly, these are what we discussed. We looked at ways of describing sets. The first way is by listing the members. The second way is by giving a word description of its members or defining a property of the set. And the third way is by using a set builder notation. Okay, using a set builder notation. All right, so the next time we meet, we'll look at the types of sets. All the best, and remember, Jesus loves you. I'm out.